Hello everyone, my name is Nima Kaviani and I'm a Principal Solutions Architect with AWS. And I'm here with my good friend Nico Cohen of Armory, and we are going to talk to you about the dynamic account management framework that we introduced to Spinnaker. So let's get it started. For the agenda, I'm going to start by providing a brief background on how credentials and accounts were previously managed for Spinnaker, and also problems we encountered and with the old way of managing accounts and credentials. Then Nico will talk about the account registration framework RFC that we got approved with the Spinnaker community and also its different elements and components. He will then show a demo of how this dynamic account registration works and what customizations and modifications you can do as a result of utilizing this new framework. We will then talk about the current progress we've made with implementing this framework and also the future work we have planned. So if you work with Spinnaker, you know that one of its superpowers is the support it has for different cloud infrastructure and different cloud providers. You can use Spinnaker to deploy resources and applications to AWS, GCP, Azure, or different cloud infrastructures. You can also use Spinnaker to deploy applications to platforms with higher levels of abstraction, platforms like Kubernetes and Cloud Foundry. Now, all of this is possible because of the one microservice in Spinnaker that integrates with the different cloud providers and cloud platforms and their APIs. This microservice is called Cloud Driver. So for Cloud Driver to authenticate against these cloud providers, it requires account information for these cloud providers. And also it requires that information and the credentials to be loaded into it. The way it's done is that these account information or credentials are provided to Cloud Driver using the YAML configuration file that already comes with the microservice, but you can also use other means to load this account information. One particular way is, for example, to use the Spring Cloud Config Server and then have it to load your account information from third-party sources, for example, GitHub or Amazon S3, or let's say HashiCorp Vault. However, one important consideration to have is that as the number of use cases and providers for Spinnaker grow, then there comes the need to add, update, or remove account information for different users using these providers. And as a result, you will have to have a strategy for doing it effectively and efficiently. Now you may ask, okay, what are the examples when I have to constantly modify or update or remove account information? One example you can think of is, for example, multi-region support for AWS services. Let's say you want to improve the resiliency of your application or make it available to your users in different parts of the world. So you may start expanding to different regions, and in order for your application to be deployed to these regions using Spinnaker, you need to provide account information to Spinnaker so that it can be done. Or for the users who leave the organization, or for the information that updates when you roll the password, you need to update your configurations so that this change or these changes are reflected in your Spinnaker configuration. As a result, you need to modify your account information. Another example is Kubernetes. With Kubernetes, it becomes even more important for you to be able to add different accounts. You may have different users deployed to the same Kubernetes cluster. You may have users deployed to different Kubernetes clusters, and you may extend those Kubernetes clusters to different regions, right? As a result, you're going to constantly have to worry about updating or changing or modifying account information. So what we have seen for the enterprise users of Spinnaker is that the number of accounts that are managed by Spinnaker can grow to many thousands. So using Spring Boot configuration, this means that reloading of the new account information needs to happen every time there's a change with account information. So you have to make the changes to your configuration and then restart Cloud Driver in order for the changes to be picked up by Cloud Driver. Now, the one issue that is very concerning for a lot of the users of Spinnaker is the amount of time it takes for Cloud Driver to restart after after you change modifications or configurations for account information. If there are thousands of accounts that you provide to your Cloud Driver, then the start time can exceed 20 minutes or so, which is a big problem, a big bottleneck for the users of Spinnaker. Also, for enterprise users of Spinnaker, they often have external services to manage their account and credential information. And they want to have a way to provide this account information to Spinnaker. Now, unless these external sources are the sources that are already supported by something like Spring Cloud Config Server, then there's no way for these enterprises to be able to provide those account information to Spinnaker. There's no way to use custom third-party services or credential registry services with the Spinnaker and have this account information be loaded by Spinnaker, right? And even then, if you manage to do that, you still need to, as I mentioned earlier, restart Cloud Driver. So this has become a big problem. This has become a big bottleneck for a lot of enterprise customers of Spinnaker. This led my friend Nico Cohen of Armory and I to start thinking about ways that we can improve this process. And then we ended up proposing a new framework for dynamic account management for Spinnaker accounts. I'm going to pass it to Nico at this point, who's going to give you some more details on how this new account management framework works and to show you a demo of how this is done.
We added dynamic account management with a specific use case in mind that we could probably have solved with a hack. But we also know that this is a pretty common problem, so we wanted to generalize the solution. We submitted an RFC to the Technical Oversight Committee. It's a great way to get feedback for larger changes. Feel free to read and contribute to existing proposals. So, what's behind this change? The idea is to standardize how credentials are loaded in all services of Spinnaker. We started with cloud operations because they are by far the ones causing most pain, and like Nima mentioned, Kubernetes in particular. But a lot of what we are going to show today will apply to other parts of Spinnaker as well, artifact credentials, CI accounts, etc. The framework itself does not add any specific feature, but instead provide a standardized and extensible way to get accounts into Spinnaker. At the same time, we want to be backward compatible, so it has to work out of the box with Spring and Spring Cloud Config. We obviously also wanted to make it possible to dynamically change credentials for the providers that did not support it yet. And finally, there is a bit of cleanup and simplification inside the service. The implementation consists of the following parts. When a credential loader starts, it will find a credential definition source, which can read credential definitions. A credential definition is just an interface that is required to have a name. The credential loader then determines which account is new, updated, or deleted by comparing the definition content and name to what is currently out there. It will remove deleted accounts, pass new and updated definition to a credential parser to convert it into a credentials, and then inject provider-specific objects. The resulting credentials go through a lifecycle handler, which will activate or deactivate accounts. In the case of cloud provider, for instance, it will schedule agents. It is then added to a credential repository, and a credential repository now has a type attached to it. So the whole process executes once per type of credentials. So a poller can optionally be configured to repeat the process at regular intervals. The whole credential loading should be idempotent. That's pretty much it. So the beauty of it is that each piece can be extended, and we expect users to do so, either directly or via plugins like I'm going to show you today. So for our demo, I'm going to use a smallish installation of Spinnaker, and I'm going to be deploying Spinnaker with a Spinnaker operator managed by Customize. And you'll see why soon. So if you're not familiar with it, the operator allows you to have the declarative configuration of Spinnaker. My colleagues Fernando and Akshay will have a more in-depth presentation of what you can do with the operator on Thursday at 1:20. So Customize is a tool that allows you to compose manifests from overlays. It has become my tool of choice when managing Spinnaker installations manually. Here I'm going to deploy an ingress as well as Spinnaker via its Spinnaker service. The ingress is for the UI and the API services. And it's using the same hostname, but just different path. The Spinnaker configuration is very simple. Note that I used the 1.23.0, which was released last week. This is the first version to support what I'm showing you today. I have a single Kubernetes account called static account, and I'm using a small MySQL instance for pipeline application storage as well as cloud caching. But it's irrelevant to what we are doing today. It could be Redis. So let's deploy this. We pipe customize build to kubectl apply, and I'll speed up the video a bit. Now we have the Spinnaker instance. I can see my account is connected, and a good way to check if your account is recognized is to query the /credential endpoint. That's what we're going to do in the terminal. And since the gateway caches the result for a few seconds, we'll query Cloud Driver service directly. So to do that, we're going to query the /credential endpoint and extract the name of the account. Okay, so you could already do all this before, but let's say that these accounts are actually stored somewhere else. It could be a custom list stored in Git, in a spreadsheet. The point is that it could be inconvenient to add to Spinnaker, or just straight up impossible if the accounts are owned by a different team. So we're going to simulate this use case with a simple web server that serves some YAML configuration. And to that end, we're adding a new customized module. We're going to add our accounts into a config map that is mounted to an Nginx server. And every time we update our config map, a new instance of Nginx rolls out with a change. We deploy our web server and check that the right content is available. And we see that we have a single account called K0. Next, we're going to point out our credential definition source to that endpoint. So that's this part that we're modifying. To demonstrate that, we're going to use a plugin that I wrote for the purpose of this demo. It's a very simple plugin, and all it does is replace a credential definition source with something that queries an endpoint. First, we're going to install the plugin. So you may already have caught some sessions talking about plugins. If not, bear with me. We're installing version 0.3.0 of the plugin. Next, we configure the plugin and point it to our web server deployed in the same namespace as Spinnaker, hence this URL. I've removed my static accounts, but I could have left it in there. It would still disappear. You can definitely write a credential definition source that aggregates different data sources. So finally, I mount a secret that contains the kubeconfig files reference. I mount that to Cloud Driver. In the production installation, I would store these in a secure location like S3, GCS, or Vault, so they can be pulled at runtime. So let's deploy that update. So this is a sped up version. When the new Cloud Driver has booted and is ready, we can see that the new account being picked up. Now let's see if we can add an account. I update and nothing. I could wait longer, but trust me, it's not going to show up. So what's going on? We didn't tell Spinnaker to reload credentials. Remember that by default, the credential definition source is queried only on startup. Fortunately, there is a new setting, credentials.poller, to enable to reload the credential source. So here we're going to reload every 30 seconds. Two important points to note. The poller is not in the plugin, so this is something you can use out of the box in 1.23.0. You'll notice that this setting is also per provider. Okay, so let's redeploy one last time. We now see our new account. And let's test reloading by removing an account and adding a new one. This time only the web server is redeployed, and we see our change. Because the account is read from an external source and does not rely on Spring, performance can be much improved. The definition is compared before any heavy processing takes place. So enabling an account is fast. So let's try with more accounts. Before doing that, we'll enable a flag in our plugin to process account definitions in parallel. We add 100 accounts and deploy. We can see the current Cloud Driver starting to enable the account sequentially. We'll delete the current replica set to better see when the cutover happens. And also not to host my cluster because it's not very big. All right, we see our accounts. Let's just display the total number of accounts. So we have a blank line, so that's 101, perfect. So let's add a new account. Only the web server is updated. All right, let's speed it up a bit and we see our new account. And similarly, if we remove a few accounts, we should see an updated number within 30 seconds. All we did today is change where CloudDriver is reading accounts from. Instead of reading it via Spring, we just pass it. And that plugin can also read JSON if you fancy that. Now, a real use case, and we have real life example of that, is that the organization already has a provisioning system to create accounts, and we'll just tap into it. It may involve perhaps token exchange of some sort, but it will also probably involve a different format. That's when you would write your own credential parser. So the nice thing is that in all this, we didn't have to write any code, triggering agents, injecting properties, etc. This is not the concern of these extensions. We didn't have to worry at all about other cloud providers. All the accounts are stored separately. And you can have the same account name in different providers. So I would recommend to only mess with credential definition source as well as credential parser. The other components can also be extended. For instance, the AWS team extended the credential repository to lazily load an account when it is not present and not have to wait 30 seconds, or however you configure your polling. So I've shown what could be done today with Kubernetes accounts, and Nima will now show you the roadmap to a broader adoption.
All right, thank you very much, Nico. So what we've done so far is that we've used the constructs in the new account management framework to convert different providers within CloudDriver to use the new constructs and the new components and benefit from all the offerings and all the good things that Nico talked about. Good news is that the new framework can replace the old model of handling account information unintrusively. This basically means that as a user of a Spinnaker, you're not going to notice any changes. Nothing is going to have to be modified from your perspective. But if you want, you will be able to, hook it up to third-party external registries that you have for your credential information. Or you can dynamically reload accounts without having to worry about restarting CloudDriver. So far, we've modified the Kubernetes provider and the Cloud Foundry provider to use the new account management framework. If you're using these two providers from version 1.223 of Spinnaker, you can in fact hook up your external credential sources and dynamically manage your credentials for Spinnaker. We're also actively working on updating the AWS provider and the ECS provider to implement the new account management framework. And the goal is to hopefully have this framework ready and available to use by the users of Spinnaker as part of Spinnaker 1.24 release. We also hope to continue converting more and more of these providers, of course, and make them available to Spinnaker users in the near future. So, introduction of the new account management framework has introduced some other benefits that we lacked in the older versions of Spinnaker. Previously, you had to have unique account names across all providers for Spinnaker in order for it to work. Now, this uniqueness requirement is only applied to each provider separately. And having similar names for your account information across different providers is possible. Exactly like Nico mentioned, you now have more flexibility in introducing custom credential sources, credential loaders, credential parsers, and credential handlers. So you can take full control of how you want to manage your account information. We have in fact implemented an end-to-end version of this full customization in the AWS account registration plugin for Spinnaker. This is something that we did in collaboration with Autodesk, and the plugin introduces a schema for providing account information from external sources to Spinnaker. It implements a parser and a loader to pull this information into Spinnaker, and eventually piggybacks on the account handler for the AWS provider to pull the new account information and make them available to other services in Spinnaker so that your cloud driver can in fact deploy to the providers that you have the account information available for. This implementation is also intended to serve as a reference point for other third-party services or other third-party resources or registries that you may want to have for your Spinnaker deployments. So if you're interested, feel free to go take a look at the link provided here and see whether you can actually utilize it for your own purpose. As for the future work, like I mentioned earlier, we plan to convert more providers to use this new account management framework that I talked about. We also welcome any help we can get from volunteers who are interested in contributing to Spinnaker and converting some of the existing providers which haven't been converted yet. We will work with you very closely if you're interested, and we make sure we support you in your journey of converting these account providers to use the new framework. We're also looking into supporting different credential sources. This includes options like HashiCorp Vault, Amazon S3, and GitHub, among others, to use the new framework. Finally, we will put out documentation and guidelines on how Spinnaker users can utilize this new plugin and hopefully solve their scaling issues that they've already seen with the older ways of account management in Spinnaker. All right, with that, I think we've covered everything we intended for this presentation. And thank you very much for joining us in this presentation. And if you have any questions or any thoughts, feel free to reach out to Nico and I on Twitter, via email, or on the Spinnaker Slack channel. Thank you very much, and enjoy the rest of your day.